So let's continue our topic. So the last session we have talked about the security threats. So wireless technology doesn't remove any old security issues, but introduces new ones. Something like US dropping, narrow level attacks, denial of service. Okay. Next, what is the US dropping? Easy to perform, almost impossible to detect this was. So by default, everything is transmitted in clear text, like username, passwords, content. So it doesn't have no security offered by the transmission medium. So different tools are available on the internet from mistakenly. Networks request protocol analyzers and so on. Password converters. These are the two techniques tools we use for the AWS dropping. So with the right equipment, it's possible to AWS drop traffic from few kilometers away. Okay. Next, MIT attack. So attacker spoofs a disassociate message from the victim. The victim starts to look from another new access point, and the attacker advertises his own uh, access point on a different channel using the real access point's MAC address. The attacker connects the real access point with the victim's MAC address. So here you can see the image how the attacker takes in the MIT attacks. So denial of service. DDoS. So the attack on transmission frequency used frequency jamming not not every typical but works. So attacker on MAC layer. So it basically attacks on the MAC layer, like spoofed or re-authentication or dissociation methods. Can't target one specific user, targets multiple users. Attacks on higher layer protocol like TCP/IP protocols and synchronous routing. Wi-Fi security. The requirements of Wi-Fi security can be broken down into two primary components. One is authentication and second one is primary. In authentication, we have two categories, user authentication and server authentication. So authentication. Keeping unauthorized users off the network, user authentication server is used, username and password are used here. So risk was data sent before secure channel established. Something like username and password or data which will be sending before the secure channel establishment. Prone to passive image dropping by attacker. The solution was establishing an encrypted channel before sending username and password. So coming to the other component was server authentication. Server authentication is digital certificate. It is used. Validation of digital certificate occurs automatically within client software. Wi-Fi security techniques. So there are some security techniques used for Wi-Fi security. These are SSID, Service Set Identifier, WEP, Wide Equivalent Privacy, 802.1x access control, wireless protected access, and IEEE 802.11i. Next. Service set identifier. What do you mean by service set identifier? Does anybody know what is the meaning of a service set identifier? What do you mean by service set identifier? SSID. Does anyone know about it? So SSID is used to identify an 802.11 network. It can be pre-configured or advertised in beacon broadcast. It is transmitted in clear text, provide very little security to the user. Next. Wide equivalent privacy. So what do you mean by wide equivalent privacy? WEP. What is the main functionality or what do you mean by WEP? So WEP provides same level of integrity as by wired network. Original security solution offered by the IEEE 802.11 standard uses RC4 encryption with pre-shelled keys and 24-bit initialization vectors. So key schedule is generated by concatenating the shared secret key with a random generated 24-bit initialization vector. 32-bit integrated check value is the number of bits in key schedule is equal to the sum of length of plain text and integrity check value. Next. So 64-bit pre-shared key was present in wide equivalent privacy, 128-bit key shared was in wide equivalent privacy. Encrypt data only between 802.11 stations. Once it enters the Wi-Fi side of the network, WEP is no longer valid. Security issues with WEP are short IP and static key. It offers very little security at all. So 802.1x access protocol. So it is designed as a general purpose network access control mechanism, not a Wi-Fi specific. Authentication each client connected to AP or switch port. So authentication is done with radius server, which tells the access point whether access to controlled part should be allowed or not. AP forces the user into an unauthorized state. User send an EAP start message. AP return an EAP message requesting the user's identity. Identify identity sent the user is then forwarded to the authentication server by AP. Authentication server authenticate user and return an accept or reject message back by the back to the AP. If accept message is returned, the AP changes the client state to unauthorized and normal traffic flows. 802.1x access protocol. So this is how an 802.1x access protocol works. WP wireless protected access. WPI is a specification of standard-based interoperable security enhancement that strongly increases the level of data protection and access control for existing and future wireless LAN systems. The user authentication is 802.1x and EAP. Temporary key integrity protocol was encryption. RC4 dynamic encryption keys are used. 48-bit uh, initialization vector was used for packet key mixing function. Fixes all issues found from WEP. Uses message integrity code Mitchell. ensures data integrity. Old hardware should be upgraded to WP. WPA comes into two flavors, WPA PSK and WPA Enterprise. Coming to the WPA PSK, use pre-shared key for SOHO environments, single master key used for all users. Coming to WPA Enterprise, for large organizations, most secure method, unique keys for each user, separate username and password for each user. WPA security and threats. So data is encrypted. For protection against eavesdropping and man in the middle attacks have been stopped by encrypting the data from the denial of service. Attack based on fake messages cannot be used. As a security precautions, if WPA equipment sees two packets with invalid MICs within a second, disassociates all its clients and stops all activity for a minute. Only two packets a minute enough to completely stop a wireless network. 802.11. So provide standard for WLAN security. Authentication with 802.1x. Data encryption with AES protocol is used. Secure for last. Secure for faster handoff. This allow roaming between access points without requiring client to fully re-authenticate to every access point will require new hardware. So the advantages are mobility, easy of installation, flexibility, cost, reliability, security, use unlicensed part of radio spectrum, roaming speed. So the limitations are interference, degradation in performance, high power consumption, limited range. So our next topic was ZigBee. What do you mean by ZigBee? How does it work? Where do you use ZigBee? Possible is no really where do we use that for the specifications. Last time, does anyone know about this? So this is specification for the suite of high-level communication protocols. You see, small, low power digital radios used on the IEEE 802.15.4 standard for wireless personal area networks, such as wireless headphones connecting with cell phones via short range radio. The technology defined the Zigbee specification is intended to be a smaller and less expensive than the WPANs, such as Bluetooth. Zigbee is targeted at radio frequency applications that require a low data rate, long battery life, and secure networking. So Zigbee is a low cost, low power wireless mesh networking proprietary standard. The low cost allows the technology to be widely deployed in wireless control and monitoring applications. The low power usage allows longer life with smaller batteries, and the mesh networking provides high reliability and large range. Zigbee protocols are intended for use in embedded applications requiring low data rates and low power consumption. Zigbee's current focus is to define a general purpose inexpensive self-organizing mesh network that can be used for industrial protocol, industrial control, embedded sensing, medical data collection, smoke and intruder warning, building automation, home automation, etc. The resulting network will use very small amounts of power. Applications of Zigbee. The applications of Zigbee are home automation, Zigbee Smart Energy, commercial billing automation, telecommunication applications, personal home and hospital care in dolls and etc. ESP8266. So where do we use this ESP8266? What is the ESP8266? So ASP8266 is an integrated chip design for the needs of a few connected world. Okay. So it offers a complete and self-contained Wi-Fi networking connection along it to either host the application or to offload all Wi-Fi networking functions from another application processor. So ESP8266 has powerful onboard processing and storage capabilities that allows it to be integrated with the sensor-specific devices through its GPIOs with minimal development upfront and minimum loading during runtime. So this is how ESP8266 looks like. The features of 8266. So the features of 8266 are taken open source. It is interactive and it will be programmable. It is low cost, simple, smart, and Wi-Fi enabled device these days. Okay, these were the specification or features of the ESP8266. So what is like ESP8266 Wi-Fi module in configuration of applications? Are as follows. In 2014, an ESP8266 Wi-Fi module was introduced and developed by third-party manufacturers like AI Thinkers, which is mainly utilized for IoT-based embedded applications development. It is capable of handling various functions of the Wi-Fi network from the another application processor. It is a SoC integrated with the TCP or IP protocol stack, which can provide microcontroller access to any type of Wi-Fi network. This article deals with the pin configuration specifications, circuit diagram applications, and alternatives of the ESP8266 Wi-Fi module. So, what is the ESP8266 Wi-Fi module? So, it is a SoC microchip mainly used for the development of endpoint IoT applications. It is referred to as a standalone wireless transceiver available at a very low price. It is used to enable the internet connection of various applications of embedded systems. It can work as either a slave or a standalone application. So the ESP8266 Wi-Fi runs as a slave to a microcontroller host, and it can be used as a Wi-Fi adapter to an type of microcontroller using UART or SPI. If the module is used as a standalone application, then it provides the functions of the microcontroller and Wi-Fi network. The ESP8266 Wi-Fi module is highly integrated with RF balloon power modules, RF transmitter and receiver, along transmitter and receiver amplifiers, filters, digital baseband power modules, external circuitry, and other necessary components. The ESP8266 Wi-Fi module is a microchip shown in the figure below. Okay, so the processor of this module is based on Tensilica Extensor Diamond Standard 106 micro and operates easily at 80 megahertz. There are different types of ESP modules designed by third-party manufacturers. They are ESP826601 designed with 8 pins, ESP826602 designed with 8 pins, 03 designed with 14 pins, and 04 designed with 14 pins. So the ESP8266 Wi-Fi module comes with a boot ROM of 64 KB, user data RAM of 80 KB, and instructions RAM of 32 KB. It supports 802.11b G and Wi-Fi networks at 2.4 GHz along with the features of I2C, SPI, I2C interfacing, DMA, and 10-bit ADC. Interfacing this module with the microcontroller can be done easily through a serial port. An external voltage converter is required only if the operating voltage exceeds 3.6 volts. It is most widely used in robotics and IoT applications due to its low cost and compact size. Simple configuration of the diagram of the ESP which you can see on the screen. So the USB kilobits is like a module configuration of the line shown in the figure. So flash mode, when GPIO and 0 and 1 pins are active high, then the module runs the program which is uploaded into it. You have to know when the GPIO 0 is active low and GPIO 1 active high. Then the module works in programming mode with the help of either serial communication or audio boot. Here are some specifications of ESP8266. So it is a 2.4 layers version module and supports WP, WPFT, WP application, and open. It uses two serial communication protocols like ITC and SPI. It provides 10-bit analog to digital conversion. The type of modulation is pulse width modulation. UART is enabled on dedicated pins, and for only transmission, it can be enabled on GPIO2. It is an IEEE 802.11b Wi-Fi module with LNA for amplifier value integrated TR switch and matching network. GPIO pins 17. Memory size of instruction RAM is 32 KB. The memory size of the instruction cache RAM is 32 KB. The size of user data RAM is 80 KB. Size of user stands systems data RAM is 16 KB. Circuit diagram of the PSP8266. So the applications of ASP8266 module are the applications of ASP8266 module appear in the access point protocols, IoT projects, wireless data log used in learning the networking fundamentals of its in smart worlds, smart home automation systems. GSM model. So GSM stands for Global System for Mobiles. It is a globally accepted standard for digital cellular communication, and GSM phone will have GSM model inside. Like any other mobile phones, we are also expressing GSM model with other microcontrollers. The GSM model used in the product the GSM 300 SIM card. So what is the need of GSM? The GSM study group aimed to provide the following through the GSM: improved spectrum efficiency, international roaming, low cost mobile sets and base stations, high quality speech, compatibility with integrated service, digital networks, support for new services. So global system for mobile communication is a globally accepted standard for digital cellular communication. GSM architecture. A GSM network consists of several functional entities whose functions and interface are defined. The GSM network can be divided into following broad parts: the mobile station, the base station subsystem, the network switching subsystem, the operation support subsystem. So this is the architecture of an GSM. So guys, is anyone having any kind of doubts regarding this class or previous sessions? Please respond.